Welcome back. So let's create the glass dust now. We already have our impact zone here in the middle, so we can use it as a source for the dust. Let's take the glass fractures first output and unpack the geometry. Transferring the impact zone group, and now we can blast everything except the impact zone. Okay. Put down a scatter node without relaxation. And let's start with 50,000. Okay. And a pop network. All points and birth simulation frames equal to 1. Okay. And this will be our dust. The next step is to create a vector field around the bullet. Where is the bullet? Here. Now the bullet is packed, if I remember correctly. Yes. So unpack. Let's go down here. We can put down a VDB, a bounding box for the bullet. Okay. And let's say yes, 0.1 everywhere for now. Probably is too much. We'll fix it later. Activate the VDB with the bound reference, and the VDB is the name of the field vel. It's a vector float, displacement, velocity, acceleration, and for now let's say 0.01. No, 0.25. Okay. And to visualize the field, we can use a vector field export. Okay. Now, volume wrangle. We need the bullet as a second input. Okay. We can say, well, first of all, the base is everything in Z direction. Okay. Okay, let's define a radius. CHF radius. Let me check the dimensions. 0.20. Well, okay, something like this for now. Now we can say take the closest point to the bullet, int pt is equal to near point. The geometry is the second input. The position is my position, and the distance is radius. Okay. If pt is greater or equal to 0, we can evaluate the distance. Vector pos is equal to point one pt. Float distance is equal to the distance between myself and pose. And now the v at vel is equal to 0, 0, and something. Let me define a factor. We can say fit distance between 0 and radius that goes from 1 to 0. Okay. By default, this is 0, not 1. Okay. Something like this. Create a null here, and this will be the bullet field. Okay. Now, before continue, let me create a random velocity attribute for the particles. Init vel. I want the particles to move in radial direction, so only in x and y direction. So we can define a float amount, float velocity x component is equal to, let's say, fit O1 of random ptnum plus something between minus amount and amount. The same for y. And now we can set the velocity as vx, vy, and 0. Okay. Inside the pop network, we already have use inherited velocity. Okay, let me check. That's it. Okay. Just a little bit. And then we can use the vector field advect by volume. The volume is bullet field. Let me see. Okay, it's too slow. We probably need to increase the eye resistance. Okay, and so on. Now we can keep tweaking the parameters until we find the right balance. It can be boring, so I don't want to waste your time. So let me give you the final values. So let's set the init velocity amount to 0.1. For the AVEP by volumes, velocity scale 1.6 and air resistance 2.86. I also used a pop wind for the noise. The noise amplitude is 0.82, swirl size 0.2. And we have something like this one. Okay, we still need to to add the collision with the second box. So we can use a merge node here. And a static object, which is the box 2 collider. And be sure to use the implicit box. Let me see. Okay. Now, what I don't like here is the impact with the surface. I would like to see a big splash over the surface. So what we can use is a pop collision behavior. And create a group called impact. So this is the group that contains the particles hitting the surface. Move to it. And then we can pop replicate this group. Group impact. Let's say constant activation 20 kilo original particles. The shape very close to the original. And set the initial velocity to let me see, 0. Something. Okay, let's check. Okay. Oh, as you can see here, probably the surface is too thin, so we can box 2 collider. We can use a bound here and set the upper padding to something like okay. Okay, not bad.